Okay, if you haven't already done so, you're going to want to make sure you watch the previous video that I made dealing with the lesson 5-7 and the table for introducing this lesson, because otherwise if you jump right into this may not make sense, because I don't know about you, but I know I'm a visual person, so having something visual to understand this concept makes it a lot easier. So let's summarize what we learned about in that when we filled out that table. So between 0 and 360 degrees, or if we're working in radians, 0 and 2 pi, the sine and cosine functions always have two solutions each. Now, if we're using our calculator, your calculator will only give the solution in the first quadrant. Now, when working with cosine functions, to find the other angle or radian measure with the same cosine value, subtract what your calculator gives you from 360 degrees, if we want to leave our values in degrees, or 2 pi if we're working with radians. Now on the sine function, on the other hand, remember we would subtract our answer from 180 degrees, or if we're dealing with radians, would be pi that we subtract our answer from. Now the tangent function is unique. The tangent function, there's always only one solution within its period. For example, if you look at this graph, so this in red represents one period of the tangent function. Remember, it's got a period of pi units. It goes from negative pi over 2 to pi over 2. Or we could even look at it as going from 0 to pi. But you can see, even if we look at it that way, there's always only going to be one solution for each value. So there's only going to be one either radian or degree. So one tangent of either an angle or a degree that it's going to only have one solution. Unlike the sine or cosine, where in one period, there's always going to be two solutions for each value. So there's going to be two angle measurements that have the same value. Now, let's talk about the general solutions. Since the sine and cosine functions, have a period of 2 pi, we add 2 pi n to each of the solutions in the interval between 0 and 2 pi. So in other words, in one period, we take whatever the solutions are and add 2 pi n to each of those, and that will give us our general solution. Now the tangent function is unique because the tangent function has just the one solution. And it also has a period of pi as opposed to 2 pi. So when you're working with finding a general solution for the tangent function, we add pi n to the solution in the interval of just one cycle or one period there. Speaking of the tangent function, since we haven't worked with the tangent function yet in that table that we did in the previous video, let's look at an example where we have to find the tangent of theta equals 2. So we want to find all solutions in the interval going from 0 to 2 pi. Now here's the problem. 2 pi for the tangent function represents 2 periods. So there is going to be two solutions because we're looking at this in 2 periods. So to find the first solution, though, here's what you're going to do. We're going to take the inverse tangent of both sides. Again, making sure that your calculator is in radians. We get a value for theta then of 1.107. Now to find the other solution, we're going to take that answer for theta. Remember, we don't have to subtract it from pi or do anything like that because this is our only solution within that one period. So now what we're going to do is we're going to apply the fact that, well, it repeats itself every pi units. So I'm going to find the other solution, I'm going to add to 1.07, I'm going to add pi. And when you do that, you get 4.249. So the other solution is going to be 4.249 between 0 and 2 pi. But again, it's important here that this other solution is only there because they're asking us in an interval that repeats the period for this function twice. So there's two solutions for this one. So when they say find the general solution, we're only using the number that we get from one period, from one cycle. So the 1.107. So the general solution for this would be the 1.017 plus pi times n. So that would be your solution. So that was where we're going to stop this video. In the next video, we're going to be looking at how to solve problems where the where it's set up as a quadratic equation. So why don't you guys watch that next video now so you can know how to do some of these problems involving where they're set up as quadratic equations or they're in quadratic form.